For my smart doorbell, I decided to record a video of the cookie thief to see who was eating the cookies. So here you can see that my email was triggered, so there's no one in the first image touching the cookie, and then in the second one there is hands there, which signaled my code to send an email at 12:57 showing who the thief was, and then this is the video I got of eating the cookies. Next, I imported different packages to help with my code. The first four, the ones we usually do, CV2 and Tails, are for changing the images, and the NumPy is for any math I needed to do. And then I had to import email. That way I was allowed to send the email to myself. And then I printed all package imported properly, and then I set the current time as the datetime package. So the next segment in my code, I do a 4x in range 0 through 1,000. That just means that I could go through 1,000 iterations of this code. If I were to actually implement this as a doorbell, I would probably prefer it to run infinitely. And so I also have a print statement just to say how many times I've gone through the loop. So for the first segment, I record the first image, and so I print recording the first image so I can see where I am in the code. I set up the camera using the video capture, and then the next segment I had to change because my Mac wasn't doing the flash properly. So for I in range 30, the temp equals camera read, and so then it returns the value of the read, and then it writes it to the test1.jpg. So that saves the first image, and then I delete the camera to close the video capture. I sleep my program for 2 seconds, so that gives 2 seconds in between the different pictures, and then I record the second image doing the same thing I did for the first, but instead of labeling the value test 1, I label it test 2, and then I collect the data on the first image. And so by doing this, I add a mask to it with different points and using mp.array. I had to do a lot of finagling trying to figure out exactly where I wanted these points to be. As you can see, I changed it drastically than what we did in class. The next segment with the gray one is when I resize the image so it takes less time, and then I change the convert color to gray, and then I do my Gaussian blur with a kernel size of 2121. That seemed to still work for me, and so it's easier to compare the different thresholds between the images. So the way that I compared the two images is by summing all the pixels of the grayscale values of the first image and then comparing that to the pixels in gray of the second image, and if it's larger than the specific threshold I determined, that is when it signals all the code to run. And so I did the same collection on the data for the second image using the same zeros and arrays to make the mask the same exact place, and then I did the same thing of using mutils to resize the image and convert the color to gray, and then added the same Gaussian blur to the image, and then the calculate difference between the first and second image, and so that's when I do the absolute value in case one was less than the other, and compare the difference between the images. And then for my threshold, I set it to be 10,000, which seemed to work every single time I tested my code. And then if the difference between the two images are greater than the threshold, that's when it signals my code to say someone is at the door, which means someone is stealing a cookie, and then it starts the camera capture to record the video. The next segment of my code is all about recording the video, so I recorded it as an MP4 file, and so I had to say the specific size of the video I wanted, printed recording, and then I only recorded my video for 49 frames, which was half the time we discussed in class, but it still gets the cookie thief catching the video and gets it before they run away. The next section of my code is creating the email message, so I use the multi-purpose internet mail extension, and I create the message. I say who it's from, which is my burner email account, and then I send it to my two emails accounts, and then I say that the email was delivered on the specific time to signal when it was taken, and then I attach the email message, and then I read in both of the images to be sent with it. The last bit of code is once again showing reading in the images and attaching the image to the email, and then logging into the Gmail server using the SMTPLIB package and sending the email as a string. Here is the first image with the mask on top of it, and then as you can see in the second image, my hands were placed there, which changed the pixel count, which triggered all the code. And basically, to determine my kernel size detection threshold value and time delay, I did a lot of trial and error because I found it worked the best for fine-tuning it. To improve the algorithm, I could have made my mask smaller so it would only see if the person touched the cookie jar instead of just moving on the couch. And then ultimately, to make the entire code better, I could have used better hardware, such as using the Raspberry Pi and a nicer camera instead of having to prop up my laptop on the table, which is kind of noticeable. And then overall recommendations, I could try and get the threshold to be more perfect and do use different timing to start the video quicker than it does. Thanks for watching.